In this video, we'll be discussing a range of topics. We'll begin with simply defining a variable and then the different variable types, how to convert a variable, and then get into some of the printing as well as more advanced object types that Python offers. We'll conclude this video with the difference between a mutable and immutable object type. We will be creating variables and interacting with them a lot in this course. You can think of a variable as a container that stores a value or a set of values in your program. When a variable is defined, the variable is stored in your computer's memory, in which you'll be able to reference it later as many times as needed. To define a new variable in your program, you will give the variable a name followed by an equal sign and then give it the value. The equal sign is considered to be what is called an assignment operator. Referring to line number 1 in this code snippet, we have an example of a variable labeled course, and it is assigned the number value 433. Then here in line 3, we have the same course variable, but it is now assigned a different value. It is a string value of MIS433. All string values begin and end with quotations. Since line 3 makes use of the same variable in line 1, in this case, the value in line 3, MIS433, replaces the original value in line 1 of 433. Knowing what type of value to store in a variable is necessary while developing your program or running any sort of analysis. Certain operations can be done on certain data value types. Keep in mind that sometimes the term value types is often referred to as data types or object types. Here in line 1, this is an example where we have a number type called an integer, which is capable of handling arithmetic operations. In line 2, it contains a print function. The variable course containing the value 433 is subtracted by 1, which is another integer value. The output results to the number 432 as shown here below the cell. In the next cell in line 1, the variable course contains a string value, but it is not capable of handling the same arithmetic operations as in the previous example. And this is because the expression within the print function course minus 1 contains two different data types. The variable course contains the string value with alphanumeric characters, whereas the number 1 is an integer value. The difference in these two particular data types or value types will result in what we call a type error. Here are some examples of variable definitions with different value types assigned. Lines 1 and 2 both contain a string value. String values begin and end with double quotes or single quotes. In line 3, we have an example of an integer type, while in line 4, we have an example of what is called a float type, which is another number data type that can perform arithmetic operations like an integer. Now, if the value in line 4 in the first quote cell is entered as the number 3 without a period, then in Python it will interpret this value as an integer data type, which is a value, a numeric value without decimal points. If there will be a number value in your program which needs to be displayed with decimal points, then this particular object will need to be defined as a float. It is possible to convert an integer to a float type, and we'll discuss this shortly. There may be times where you must find out which value type is stored in a variable, and this could easily be determined by using the type function as shown in line 2 in this example. The type function is called, and the defined variable from line 1 is included within parentheses. The output, int, which refers to an integer value type, is returned. The next code cell shows the output of the course variable as a string type. And the last code cell makes use of the type function without including a defined variable within it. Instead, the raw string value is included within the parentheses. Keep in mind that there are many different value types or object types in Python, and we'll be discussing those throughout the semester. It may be necessary to convert a defined variable that contains a specific value type to a different value type by using the type conversion functions. The illustration here shows 3 conversion type functions for a string, integer, and a float. A simplified example of this is shown in line 1 and 2, where the course number variable contains an integer of 433. Then in line 2, the str function is applied with the course number variable inside of it, which is then again assigned to the original course number variable. To further illustrate this, let's say that we define a variable called course name containing MIS, a string value. Next, the course number variable is defined with the value 433, an integer. If we try to concatenate these two variables together using course name plus course number, this will return a type error since we're trying to combine two different data types. In order to concatenate or combine the two values together, we can apply the str function on course number, which will change the 433 integer value type into a string. That way, we can combine them and the output will return MIS 433 together as a string. Be aware that not any variable can be converted to any data type. In this example, we have defined a variable named course containing a string value of MIS 433. Since the value contains alphanumeric characters, meaning that the value contains numbers, letters, and space characters, the int function will not work. As you can see here, there is a value error message. If, however, the variable that has the string value only contains numbers, as shown here in line 1, then it is possible to convert the variable to an integer type. And this is something that's often done when data is scraped from websites. When defining a variable in your program, it is best to use simple descriptive words as it relates to the variable. Avoid long variable names and abbreviate when you can. Keep in mind that Python does not allow variable names with space characters in between words or abbreviations. A solution would be using the underscore sign in between words or abbreviations. For more information about standard naming conventions in Python, you can visit the realpython.com link provided here. In order to output information in your program or in your Python script, you must use a print function. To print content from a variable, the name of the variable must be included inside the print function, as you've seen in previous examples. When it comes down to printing a variable, do not use quotation marks, as this will print the variable name as a string rather than print out the content stored within the variable. Let's take a look at some ways to output information using the print function. We see the first example in lines 2 to 3 where the variable is first defined and then printed out. Line 7 outputs the same information but using two values and two different value types separated by a comma. Line 11 prints out one string value that does not belong to a variable, like line 7. And line 15 prints out an integer value. Line 19 prints out a list, which is a common data type used in analytics. A list may contain multiple values with different types separated by a comma. A list data type must begin and end with square brackets. The output to the print statement here is a list that contains 6 items, also known as elements, that are either string or integer values. There are different categories of data, and as we've seen, data could be numeric or alphanumeric, which may be categorized as integers, floats, or strings. Taking it a step further, data could also be stored in different structures. In Python, value types, also known as object types, are not limited to just integers, floats, and strings, but to other object types such as a list, a tuple, and a dictionary. It is crucial to understand the capabilities of each object type. We will not cover every object type that Python offers, as this is not within the scope of this course, but some common object types we'll be interacting with are listed here. Let's cover some of them. A list is used to store a sequence of heterogeneous data, which means it can consist of different object types or value types. For example, the variable myList contains a list with different values such as the letter A, the number 1, a true Boolean value, and a float value of 3.14. Each one of these elements or items in the list contains a hidden index value, which is used as a reference point. A list could also be modified or ordered as needed. Here's an example of a variable that's assigned a list containing 7 elements. The elements in the list contain strings and integers. Each element contains an index value. By default, the index value for a list begins with the number 0 and increments by 1 for each additional element in the list. This is an example of a list that contains 2 elements, where one element is a string value and the other element is an integer value. Whereas this list contains only one element. To search a specific element or a range of elements within a list, we need to call the variable and follow it with a pair of square brackets. Within the square brackets will be the index value that locates the elements. This example shows output returned with the value m when searching for the index 0 inside course. Here's another example of index slicing where we have course inside brackets is 0:3. Remember 3, the index value 3 is excluded, so it will not be returned as part of the output. It is also possible to retrieve elements starting from the back of the list by using negative indexing, With negative indexing, the starting point of the first element in the back of the list is -1, and then it increments by 1 after that. Here's an example of negative indexing. To retrieve the last element within the course variable, we would use -1 inside square brackets. This is another example of locating the element in index position -5. And this last code cell is an example of slicing using negative indexes. Indexing also allows us to modify elements within a list. Here, the course list has 3 elements. The last element is missing some letters in the title of the course. To make the necessary changes, we need to select the element or the element's index position and assign it the correct string value. The second code cell in line 1 calls the variable with the value 2 in brackets, which represents the third element of the list since the first element of the list begins with 0. This is followed by the assignment operator and then the new string value to replace the old one. The print function returns the output that's updated. Almost all data types or object types consist of methods. We attach methods to a variable to perform operations. For example, to add new elements to an existing list that has been defined, we could use the append method. Now let's use the course variable that contains 3 elements. We can append a new value to the list by attaching the method to the variable. This is done by calling the variable, then entering a period followed by the method name and a set of parentheses. Inside the parentheses is a new value to add to the list, and in this case it is a string value DL for distance learning. Here's another example of using the count method where it counts the number of times a particular value appears in the list. A dictionary is another object type or data type that can store a sequence of data, but using it in a different structure than a list. Dictionary variables are defined using curly brackets, and within the curly brackets there is a key followed by a colon symbol followed by a value. Think of this as an actual dictionary when looking up a word and its definition. The word is considered to be the dictionary key, and the definition is the dictionary value. As with lists, a dictionary could hold multiple elements with different object types and also has an index, but the index will be considered the dictionary key rather than specific integer numbers. Example 1 shows a course variable with a dictionary value assigned. The key is the string value MIS433 and the value is the integer of 001. In example 2, the dictionary has a value containing a list with 2 elements. Keep in mind that dictionary keys are not capable of holding a list, whereas the value can. To add additional new key value pairs within an existing dictionary variable, we would need to call the variable followed by a pair of square brackets with the name of the new key followed by the assignment operator and the value that will be attached to that key. As mentioned earlier, most object types have a set of methods that could be used. Here's a list of methods related to a dictionary. In this example, the keys method is used on the course dictionary variable that has a couple of key value pairs. This will output all the keys that are inside this dictionary variable. A set is another object type, not to be confused with a dictionary, although it does use curly brackets when it's being defined. A set does not contain an index value and does not allow for duplicate elements within the sequence. Here we have an example where a variable is assigned two duplicated elements. When we try to print the set will only return the unique value. A tuple or tuple is another object type that can store a sequence of elements. It is defined by using a set of parentheses. The values stored inside a tuple cannot be modified. There's simply not enough time to cover each method for each object type, so I encourage you to practice some of the methods that are highlighted here in red. w3schools.com is a great website with easy to follow code and instruction. This site contains some hands-on practice that you could possibly benefit from. I want to conclude by bringing to your attention the difference between mutable and immutable data types. Some data types or object types are capable of being modified, whereas some cannot. Those object types that cannot be modified are considered to be immutable objects, whereas those type of objects that can be modified are called mutable objects. These are terms that you may encounter in the future, so it's good to be aware of them.